Hello, good day everyone. Today I'll be explaining the similarities and differences between mixtures and solutions using a Venn diagram. So before we begin, let me ask you this question. What is a mixture? A mixture, as defined in my Venn diagram, is the result of combining two or more substances. A mixture can be separated through physical means, such as distillation, evaporation, sedimentation, and much more. Mixtures are further classified into two: homogeneous mixtures, which are mixtures that have a uniform composition throughout, and only have one phase. A phase is a region of uniform composition and properties. You can tell when a mixture is homogeneous by seeing if the solute is fully dissolved in the solvent. I'll expound further on solute and solvent later on. Anyways, here are two examples of homogeneous mixtures. A cup of coffee. It is considered a homogeneous mixture because it has uniform composition. The second example shown is a bottle of Listerine mouthwash. The reason why it is a homogeneous mixture is the same as the previous example. It has uniform composition throughout the mixture. Let's proceed to the second type of mixture, which are heterogeneous mixtures. These mixtures are the complete opposite of homogeneous mixtures. Stated in my Venn diagram, their composition isn't uniform throughout the mixture and have more than one phase. Heterogeneous mixtures are further separated into two types: colloids, which appear to be homogeneous to the naked eye, but when observed through a microscope are actually heterogeneous mixtures; and suspensions, which are heterogeneous mixtures that are mainly composed of a solid and liquid, in which the solid is distributed throughout the liquid without being dissolved or mixed. Here are the examples for the heterogeneous mixtures. Sand and water. It is a heterogeneous mixture because, as stated earlier, the mixture isn't uniform and is also considered a suspension because the sand is distributed throughout the water but it isn't dissolved. And blood. It is considered a heterogeneous mixture but appears homogeneous to the naked eye. It is classified as a colloid because of that reason. However, when observed through a microscope, it is a heterogeneous mixture composed of red blood cells, plasma, white blood cells, and more. Let's move on to solutions. So let me ask you another question. What are solutions? Solutions are a type of homogeneous mixture composed of a solute, the substance being dissolved, and the solvent, the substance used to dissolve the solute. Solutions, stated in my Venn diagram, have concentration, which is the amount of solute dissolved in the solvent. Solutions also have saturation. Saturation is the amount of solute that is able to be dissolved in the solvent before the solvent can no longer dissolve any solute. Also, saturation varies differently from solution to solution, and there are factors that determine saturation. But what are these factors? Well, there are four key factors that affect the saturation of a solution, which are the chemical makeup of the substances used to make the solution, or in other words, What are the substances made of used to make the solution? The temperature of the solution. This factor is also important in the process of making supersaturated solutions, which I'll explain later on. The concentration and amount of solute, and finally, the solution's pressure. Saturation is also separated into three main types. Unsaturated solution, which is the first type of saturation, as shown in my Venn diagram. It is a solution which has dissolved an amount of solute below the saturation point, and more can be dissolved into the solvent. Let's move on to the next type of saturation, which is the saturated solution. It is a solution that has the maximum amount of solute dissolved in the solvent. If more solute is added, it will settle at the bottom. Now, let's proceed to the last type of saturation, which is the supersaturated solution. It is a solution that has more than the maximum amount of solute dissolved in it. This is only possible through adding the maximum amount of solute to the solvent, then adding more solute into the solvent. After, this solution is heated up to dissolve the excess solute. Finally, it is gradually cooled. This supersaturated solution is unstable, and if disturbed, the excess solute crystallizes. Now, here are the examples of all three types of saturation. All three examples are lemonade. However, each have varying amounts of sugar added to them. The first picture shows an unsaturated lemonade, in which the amount of sugar in it is below the saturation point, and more sugar can be added. The second picture shows a saturated lemonade, in which the maximum amount of sugar has been added, and if more sugar gets added, it will settle at the bottom of the glass. The third picture shows a supersaturated lemonade, in which more than the maximum amount of sugar has been added. Now that we've discussed the differences between mixtures and solutions, let's find out what are their similarities. Solutions are a type of homogeneous mixture. This similarity leads to many more, such as mixtures and solutions are both composed of two or more substances. They're both able to be separated through physical means. Both retain their chemical properties. Both only have one phase. And both can be found everywhere in daily life. So now that I am done discussing my Venn diagram, hopefully you learned something from this video. Thank you and goodbye.